Hello everyone, and I hope that you're doing well. Today we are doing a review of a BGCSE past paper. This is a chemistry paper 1 from the year 2022. Please remember, before you start the examination, always write your school number, your candidate number, your surname, and also your initials. Again, please remember to read through all the instructions carefully and ensure that you understand each instruction. If you should have any questions or queries, please clarify those with your examiner before the examination begin. They will also provide you with a nice periodic table that you can use to assist with any question that necessary. And so with that said, let's jump into question number 1. And for question number 1, it said the diagrams show 4 methods of separation. Which separation technique is used to separate oil and water? And so let's look at the diagrams and notice this is an evaporating dish. So it used to separate dissolved solids from the liquid. Again, the liquid will evaporate, leave a solid behind. For example, salt water. And if you want the salt, then evaporate the water and leave the salt behind. Now, for this, which is a filter funnel, this is really separate liquid from suspended solid. For example, you have stone in water. You separate this water from the stone. Here, option C, you'll use this apparatus here to separate oil from water. You can turn the knob and release the more dense liquid first. So water will be more dense than the oil. The oil will float on top. So the water will come out first. You turn the knob off to stop it or just prevent the oil from flowing out. And here you have a simple distillation apparatus here, and this is used to separate liquid from dissolved solid. So notice the difference between option A and D. They are pretty much vice versa. All right. So if you have salt water here, you can get the pure water from the salt water. And in this case, you get the salt and the water will be evaporated. All right. So let's jump into our next question, as number 1 is C. For question number 2, the question reads that the diagrams show 4 uses of iron. It's in which of these is the iron most likely to rust? And option C is the correct answer, and just look at the information provided below each diagram. And so we have an iron bucket, and this was electroplated with zinc. And of course, because it is electroplated, then it's going to be more difficult to rust. You have aluminum wire around iron core, and so the aluminum will prevent the iron from rusting really easy. But you have iron inches on a gate, and it is not painted. They never say it's painted, never say it's coated. So therefore, it is exposed to oxygen and also moisture. So therefore you need moisture and oxygen to cause rusting in iron. And for option D, it says painted iron fence. Once it's painted, it's going to be difficult for it to be oxidized. All right. And remember, rust here is iron oxide. In fact, iron 2 oxide. So the formula for rust is Fe2O3. All right. Question number 3. This question reads that what is the most appropriate unit to determine the amount of a substance? And notice this said amount of a substance, right? And amount of a substance is really measured in moles. So moles is the straightforward answer, right? The information here, kilograms used to measure mass, liters used to measure volume, and meters measure length. So moles really is the amount of substance. Question number 4. And it reads that a student carries out an experiment to find out how fast 4 centimeter long pieces of magnesium ribbon dissolve in 5 centimeter cube sample of sulfuric acid at different temperatures. It said which piece of apparatus is not needed. And so if you look at this carefully, it gives you a length, all right? And it also gives you a volume, and you have different temperatures. So your thermometer is needed, a stopwatch is needed to determine how fast the reaction is going. The measuring cylinder is needed to measure the volume of the substance, and you do not need a balance because here there is no mass required based upon this reaction. So option A is the correct one. For question number 5, is what is the effect on particles when the temperature of a substance is increased? And so, if you know about the kinetic theory of matter, it kind of explains it that of course when you increase temperature, the particles will gain energy. And so therefore they will move much faster. And so therefore A is correct. Particles gain energy and move faster. All right. For the questions that need explanation, I will do those, but I'm going to run through as quickly as possible. because there are some questions that are just straightforward right off the bat. Now, question number 6 is which statements accurately describe what happens when a solid becomes a liquid and a liquid becomes a solid. So for a solid to become a liquid, you must apply heat to it. So heat energy is increased. And for liquid to become liquid becomes a gas, you must apply heat as well to it. So in both cases, heat must be applied, and hence option A is the correct answer. All right, that is a very easy question. No need to explain that. We all should be good on that now. Question number 7 is which pair of processes is explained by the kinetic theory, which I just talked about the kinetic theory up top. And if you look at the option, in terms of movement of substances, right? Corrosion and rusting is not explaining kinetic theory because, again, kinetic refers to movement, right? And once you're going to move, you need some form of energy to cause that movement. So diffusion of particles and collision, and this one is saying elastic collision, which means they will collide and then move apart from each other. And so therefore, diffusion and elastic collision really explain the kinetic theory, because as particles move based on kinetic energy, and again, the more kinetic energy you have, the faster they move, which means the faster the fusion. Faster the fusion is more collision, and of course, they will bounce off each other as well. The others really not correct. So you can go through those, pause and go through them to make sure that you understand why B is the correct one. Number 8 is how does magnesium become a stable particle? And I want to kind of understand this. Magnesium itself, right? For it to become a stable particle, it therefore should not have any excess electrons, all right? And so what's going to happen for it to become stable, it will combine with another element. And how we're going to do this, it will actually lose 2 electrons and become a positive particle. So how you, matter of fact, I'm going to clarify something here, matter of fact. One thing you should know is that atoms in their natural elementary state, they tend to be stable. Or, matter of fact, let's not even use the word stable. They have no charge, right? Because having no charge and stable is 2 different things. So the atoms in their natural way, in their natural form, they have no charge. Why? Because the proton equals to the number of electrons. But for it to become stable, which means now it's reacting with something, and so therefore the charge and ions will become 0, the total charge in a compound, because a compound is a relatively stable chemical. And so magnesium loses 2 electrons and become positive charge, and so the outer shell has 8 electrons, which represents a stable shell, or what they call an octet. All right, so once an octet is reached, then we say that the element is pretty much represent a stable form of an atom. All right, so question number 9 is which part of the atom contributes to the mass and charge? And so based on these particles, as I go down the list, electron has nothing to do with the mass at all. But of course, electron can contribute to its charge. All right, and B, neutron. Neutron only contributes to the mass only. And of course, the orbit neither affects the mass or the charge, but the proton do affect the charge and also the mass. All right, because of course, if you have more protons than electrons, then it becomes positive. If you have less protons than electrons, it becomes negative. And of course, proton is in the nucleus, so therefore it do contribute to the mass. Question number 10. Is a carbon may be written using the symbol, and you have C, you have 12 up top, and you have 6 at the bottom. And so just to point out that the bigger number is always the mass number, because sometimes they can place them side by side, or the bigger number could be at the bottom. So it doesn't matter where they place them. The fact that the bigger number is always the mass, the smaller number represents the proton number, which is the same thing as the number of electrons, all right, and is also referred to as the atomic number. All right, so it's which statement correctly describe these 2 numbers? Again, the bigger number is the mass. So 12 is the mass, and 6 is the atomic number, same thing as the proton number, and also number of electrons. All right, so option A is correct. Number 11, it said that the electronic structure of atom X and Y are shown. So I have X and Y here. I just put some extra thing here to make it fast and easier. And I want to just point out something for structure X. It has one valence electron, so we consider to be a positive 1, right? And for Y, it has 5 valence electrons, so it will become a negative 3. And so the easy way to do this is just to do the crisscross thing. So we cross over and carry 1 to the bottom of Y and 3 to the bottom of X. And so the formula for this, because the question actually reads, give the chemical formula for the compound form when X and Y react. And so if X should react with Y, then you're going to have X3 and Y1. All right, of course, you don't write 1 when you're writing compound formula. All right, just to make a note. But for mathematical purposes, you can always cross the 1 down, but you should not write it when you're writing the formula. All right, so it is a ratio of 3 to 1 in terms of the amount of atoms of each that is required. All right, so next question is question 12. A matter of fact, it's a diagram. The diagram should be used to answer question 12 and question 13. And so we have calcium 2 plus here, and we have chlorine, which is negative 1, but is multiplied by 2. And of course, you're going to see the reason why. It's kind of the same concept up top. We cross over the charges really to determine how many atoms of each you require. So if calcium is 2 plus and chlorine is negative 1, therefore we're going to require only 1 calcium and 2 chlorine, all right, to make it a full compound or a neutral compound. All right, so question number 12 reads now. We say, how did calcium and chlorine become charged particles? Again, remember that calcium is from group 2, so therefore it loses 2 electrons to become 2 positive, right? So when you lose electron, become positive. And of course, chlorine will gain electron and become a negative. All right, but of course we have 2 chlorine, so there's something must be considered here, right? So the option that is correct, without going through the others, is that 2 chlorine atoms, 2 chlorine atoms gain 1 electron each, because again, it's a negative 1 and you require 2 of them, okay? And so for the calcium partner, it said 1 electron each from a calcium atom. So the calcium give up 2 electrons, 1 to each chlorine, all right? So option C is the correct version of this answer. Question 13, it said which type of bonding is shown in the diagram? Again, since you have a metal and a non-metal, then it must be ionic bonding. All right, so ionic bonding is the correct answer. Remember that covalent bonding requires 2 non-metals, right? And hydrogen bond require a bond between hydrogen and another element, all right, or compound. And a metallic bond only requires, well, it involves only metals, all right? All right, so question number 14. It said the reaction between magnesium and carbon dioxide is represented by the equation shown. And so you have magnesium plus carbon dioxide to give you magnesium oxide and carbon. And of course, the reaction is balanced as written. And it said which statement describes what happened in this reaction. All right, and so just to point out where it says carbon is oxidized. A matter of fact, if you notice, carbon is losing the oxygen, so it cannot be oxidized. That couldn't be the answer there. All right, and it said magnesium is reduced. Magnesium gain oxygen, so therefore it is oxidized, right? And it said need oxidation reduction, which is not correct. So the correct version here said the carbon in carbon dioxide is reduced. Why? Because the carbon lost oxygen. All right, that's why you have carbon by itself, and oxygen will go to the magnesium. So the magnesium is oxidized, carbon is reduced. All right, and so definitely also we have loss of oxygen to produce carbon. So that's just a notation that is guiding this question. All right, so question number 15. It's the bones are made up of calcium phosphate. All right, and of course we should understand how to write this formula, because again, calcium is from group 2, so it's 2 plus. Phosphate is a diatomic ion, and so it is a negative 3. So of course we cross over the 2 and the 3 to get Ca3, PO4 in bracket 2. All right, so the question now asks what is the correct relative molecular mass, which is also represented as Mr of calcium phosphate? And to work this out, I mean, you should be pro by now, is thus calcium, which is the mass number. Look at the periodic table. That's why they give a nice one too. So it's a 40 multiplied by 3 plus 31, which is the mass number of phosphorus, multiplied by 2 because you have 2 phosphorus. Anything inside the bracket is multiplied by 2 outside. And for oxygen, is 16 is the mass number, but is multiplied by 8 because you have 4 oxygen inside, multiplied by the 2 outside, that's 8 oxygen. And so you get a total of 310 grams. All right, so option D is the correct answer there. For question number 16, it said, what is the valency number of SN or tin in SnO2? And to work this out, there are 2 ways you can actually do this, right? What I did is to use what they call the oxidation number, because that's what they're actually asking you to calculate the oxidation number, really. And to do this, what you should remember, based on oxidation state, oxidation number, is that the total oxidation state or oxidation number of a compound equal to 0. And so therefore I could say Sn plus 2 multiplied by negative 2. The reason for that is because oxygen tend to be negative 2. There's a negative 2 multiplied by 2. That's why I get it here. So that will be Sn plus negative 4 equal to 0. And of course, by making Sn the subject of a formula, we have Sn equals to positive 4. And so positive 4 is the correct answer. All right? All right. All right, let's now go into question number 17. It's a substance Y has the following properties. It is slippery when touched, tastes bitter, turns red litmus paper blue. By now you should know what that is, right? They say, how should substance Y be classified? Turn it blue, you should know what that is. It must be a base or alkaline, right? And so the only thing that is matching right here is alkaline. The last one actually gave away exactly what it is, right? But of course we know that bases or alkaline there tend to be bitter and slippery as well. And that is why even soap, because soap contains base, right? Normally sodium hydroxide is used to make soap generally, and that's why soap tend to be a little bit slippery. All right, matter of fact, not even slippery, slippery really. All right. Number 18. He said, which ion is present in all alkaline solution? And for you to have an alkaline solution, you must have hydroxide, right? That's what defines alkalines, hydroxide. All right. All right. So an OH is a minus charge, as I mentioned. That, so you can even use these to kind of note the charges right here. All right. Of the different ions that we have: ammonium, hydrogen, and the sulfate ion. All right. Because of course you may use them again, especially in paper 2 and 3. Well, question number 19 is a solution, and I make sure I highlight solution here for a particular reason as I go down. It said a solution contains barium and silver ions. It said, which of the following ions could also be present? And again, for a solution, must be uniform throughout. And so therefore, you're going to have nitrates only. And I put a notation here because the nitrate is the only substance right here that will not form a precipitate with all of them in the same container. All right, because of course, you know, sulfate could form precipitate. Chloride and also chloride, I should say, can also form precipitate. So to make it be a homogeneous mixture, then you only require nitrates. All right. All right. 20. It said, which method may be used to determine the concentration of nitric acid? All right. And so you want to determine the concentration of something. The best method to use here is really titration. Distillation is a separation technique, right? Filtration is a separation technique again. Precipitation is when you mix substances and you get solid forming. That will not help you. None of those three actually help you to determine any concentration of nothing. So definitely D is off the bat the correct answer. All right, question number 21. It said a tourist spilled vinegar dressing on a limestone table and noticed tiny bubbles were produced. It said which word equation correctly shows the reaction? And just to make a note right here, limestone is calcium carbonate, right? So it's a carbonate, and vinegar is an acid, acetic acid. So think about an acid and carbonate, what you should get as a result. So when a carbonate reacts with an acid, you get salt, carbon dioxide, and water. All right, and that is why option A is the correct answer. Vinegar is acidic, limestone is a carbonate, and so carbonate plus acid, salt, carbon dioxide, and water will be the products. All right, so there's no need to explain that. All right, question number 22 is a street lights have a golden yellow glow. It's a which ion is responsible for this color? And straight off the bat, it is sodium. Alright, so sodium will be in those type of lights that give off that yellow glow. All right, question number 23. Is a diamond graphite or macromolecules, which means they are large molecules, right? So which statement about diamond and graphite is true? All right, and remember they're made up of just pure carbon, right? And so carbon in itself insoluble in water. So if they are just carbon, then they won't be able to dissolve in water at all. All right. Even though, just to make a note, even though graphite can conduct electricity, all right, it doesn't mean that it's able to dissolve. All right, because we tend to say that polar substances can dissolve. All right, but graphite is a conductor, diamond isn't a conductor of electricity. I just want to make a note of that. All right, so B said that they have the same crystalline structure, which is not true because, of course, diamond is stronger than graphite itself, and the difference in the tetrahedral structure. So they're different, in fact. The same degree of hardness, no, because graphite is softer, diamond is harder. All right, they have the same electrical conductivity, no. As I said, that graphite can conduct electricity, diamond no. All right, and so definitely A is the correct answer. All right, so question number 24. I'm getting close to the midpoint of this review. And so the diagram shows 4 particles, and so we have 4 particles right here. I make some notation there. Well, that's an X really. And so based on the question, so which two diagrams show atoms that are isotopes of each other? And so just to make a note that the only one that can form isotope in this question is really number 1. So if you see number 1 in it, it is wrong. And why we know that is because to form isotopes, right, it must be the same element. And how know it is the same element? The one thing that proves that 2 atoms or the same elements or from the same elements is the proton number. For you to be the same element or the same atom, the proton number must be the same. And so 2, 3, and 4, they are isotopes of each other. So guess what? The options now must be centered around 2, 3, and 4. And so based on the options given, they have 2 and 4 together, right? And so 2 and 4 is the correct answer, but it could also be 3 and 4 as well, right? All right, just to make note of that. All right, so we have 2 possibilities right there in terms of isotopes. All right, and also we could have 2 and 3. So it's not just, yes, so we could have 2 and 4, 3 and 4, and also 2 and 3. So we actually have 3 different, let me see something, 2 and 3. Let's go back a little bit because I said 2 and 3, and 2 and 3 is a possibility. Yeah, because they have the same proton number. No, lie. 2 and 3 cannot be. Why 2 and 3 cannot work? Because if you notice, 2 and 3, they're the exact same thing, which means 3 protons, 3 neutrons. So definitely only based on these structures, the only possibility is really 2 and 4 and 3 and 4. Because again, 2 and 3, they are the exact same thing. All right. And again, the neutron number must be different. And once the neutron number is different with the same proton, you're going to get a different mass, right? Because an isotope must be the same element with a different mass number due to a difference in the number of neutron. All right, so D is the correct option there. Question number 25. This is a sweet paper though, I like it. Now, question number 25 is a gas C bleaches litmus paper. What is gas C? This one is chlorine. They even use the word bleach. But the fact though, chlorine really changed litmus paper, bleach it, decolorize it. Because bleach tend to decolorize most pigment. All right, so definitely chlorine is the answer, right? And chlorine is found in bleach. All right, question number 26. And this one reads now that aragonite, which is a form of calcium carbonate, is mined in the Bahamas. Name the ore from which metal can be extracted using aragonite. And aragonite is used in extraction of iron, and the ore for iron is hematite. And so option C is the correct. Asbestos is not a ore, just to make a mention of that. Bauxite is not a ore as well. Bauxite is a ore, but is used to produce aluminum, not iron, because this actually said using, well, Bauxite is a horse, so that could be an option. But the fact that calcium carbonate is used, just to make mention, this is a key part here. The use of calcium carbonate, right? So calcium carbonate is used to extract iron by using hematite. All right, rock salt, no. And the other name for rock salt is halite. All right, just a mention of that. And there's natural occurring salt in rock form. All right, so question number 27 is that some properties of 4 elements, W, X, Y, and Z, are listed. And this may not be so clear in terms of, so let me just read through this real quick. For 1, it said that W melts at 1,410 degrees Celsius and forms an acidic oxide. So once you form acidic oxide, you know this is a non-metal, right? Okay. So for X now, it's X has a high density and has a loud sound when hit. So that tend to be a metal. Because once it hit metal, it's going to give you a strong vibration, right? Non-metals will give you a lower sound, all right? But metals give you a higher sound because of the vibration that passes through it easy, conduct sound really well. Y, it's a Y acts as a catalyst, and its oxide reacts with acid. So if its oxides reacts with acid, then it must be a metal oxide, all right? I just make mention of that, so that's a metal right there. And for Z is a lemon yellow solid, which is insoluble in water. And if there's an element that is lemon yellow, we know that off the bat that is sulfur, and sulfur is a non-metal from group 6, right? So which of the elements are metals? And so the correct answer is going to be option 2 and 3. And so therefore B is the correct answer there. All right, let's slide on into question number 28. And for question number 28, this is the energy level diagram for the reaction between magnesium and hydrochloric acid is shown. And so you have magnesium and hydrochloric acid up here, high energy, and then at the product, you have magnesium chloride and hydrogen gas. So these are the products right here, which is low energy based up on the graph. So which statement about the reaction is not correct? All right, and so let's go down to the options so we can read through them. So which of them is not correct? And A is that energy is given out during the reaction, which indicate that is exothermic. So therefore it is a true statement, because if you have a low temperature or a low energy at the end, that means energy must be given out. So it's a true statement. We're looking for the one that is not true. All right, so this is an exothermic reaction. All right, so B now said the products are at the lower energy level than the reactants. Correct, because the products here, the reactants on top, so the energy in the products are lower, which is a true statement. But for C now, so the reaction is endothermic, which is contradicting to A, and A is a correct statement. So therefore C is the incorrect statement. All right, for D, it's the temperature rises during the reaction. The temperature rise during the reaction, they're not shown right here, but what they call the intermediates when they form ions. And that is because you require energy to break those bonds. And that energy that is needed is called the activation energy. So once the activation energy has to go up, because it must be the highest point of the reaction when you produce the free radicals or the ions. All right. So in other words, to break the bond of hydrochloric acid, you need energy for that. And so the energy will increase, and then it will decrease because energy will be lost to the environment. All right, so if you look at your exothermic and endothermic graphs, you actually see that in the middle for most diagrams, all right? So C is indeed the correct answer. 29, it said which metal could not be used for electroplating by using an aqueous solution? And it said not be used, all right? So of course we could use copper. Lithium cannot be used as cannot be used by electroplating at all. And again, the reason for that is because it's not really a transitional metal. All right. And so lithium itself may react with the aqueous solution very easily. But the transitional metals, no, they will not react with the solution that easily, just to make mention of that. All right. And that's why we have deposit. We can have copper deposit, silver deposit, zinc deposit at the cathode, right, which is negative. All right. And so that is the answer there. Lithium will be too reactive for it. It will react with the solution instead. And so it cannot work as in terms of electroplating. All right, 30. And we're going close to the end. It said, which of the following is an electrolyte? All right, and so just to know what an electrolyte is a substance that can be easily decomposed by passing electric current through it. All right, that's what an electrolyte is. You can decompose it by passing electrolyte through it. And so if you have distilled water with pure water, it's very difficult to break down by passing current through it. So distilled water is not correct. A matter of fact, easy way to look at it to determine if it's an electrolyte is that in a solution form, you'll have ion present. In other words, it will disassociate ions or discharge ions in an aqueous form or a solution form. And so distilled water will not do that. Ethanol will not do it. A matter of fact, ethanol, as you know, it's a non-polar substance, right? Sugar solution is the same thing, will not discharge ions or dissipate ions or disassociate ions in a solution form, but tap water is. And the reason why tap water is different from distilled water is because tap water, generally speaking, not all tap water, depends on where you get the water from, but tap water generally contain dissolved ions, all right? And so once you have the dissolved ions or minerals, then it will give off some ions in the solution form. Electricity could pass through it easier, all right? And it will break down much easier because of those ions that are present. All right, the question number 31. It said, which of the following is the correct order of reactivity of metals from the most reactive to the least reactive based on their reaction with water? All right, so I have a notation there on the right, but let's look at the options really quick. So we only have magnesium, calcium, potassium, and sodium in all of them, right? So those are the 4 elements in different order. Now let's think about why option C is the correct order. And it's simple this. The group one metals, they are more reactive than the group 2. So the group 1 must come before the group 2, right? So sodium and potassium, they are group 1. Calcium and magnesium, they are group 2, right? So the group 1 must come before the group 2. That's one way. That's one way. So off the bat, you know that A will be incorrect and B will also be incorrect because a group 2 cannot come before group 1. And then the next thing now, going down the group of the metal, reaction or reactivity increases, right? And so therefore, potassium will be more reactive than the sodium, all right, in terms of reacting the water. And the calcium will be more reactive than the magnesium. So therefore, option C is the correct version. All right, and so you can make a note of this notation there in red on the side to guide you when you're doing reactivity of metals. All right, and again, there's a number of reasons for that too, you know, because let's point them out real quick. Because going across the period, which is moving from group 1 to group 2, why reaction decrease some metal is simply because of the atomic radii. Because atomic radii decrease going across the period for metals and so become less reactive because the electrons are closer to the nucleus and so they're held much tighter to the atom. Going down the group, atomic radii increases and so the valence electrons are further away from the nucleus. So you have less what they call proton pulling, all right? So you have less energy required for those reactions as they get bigger or the atomic radii increases down the group. All right, so there are many explanations for this one thing. So you can just go through it, look at atomic radii, look at the trends in the periodic table, and you should be good. Question number 32 is that which of the following is an acidic salt? All right, and again with this question, I just see the question, the answer, you should know it. Acidic salt because the H is present in the salt, so become an acidic salt, right? And of course, because normally you react this with a very strong acid. And so sodium hydrogen sulfate, or what you may call sodium bisulfate, it is an acidic salt. The presence of this hydrogen makes it acidic. All right, so D is the correct answer for 32. There's no much more explanation for that. I think that one is a straightforward one. All right, question number 33 is that which element would gain 1 electron when forming a compound? Gain 1, simple gain 1 electron. And of course, to gain 1 electron, the elements must be from group 7, right? And so fluorine is a group 7 element right here. So definitely gain 1 electron. Helium is a group 0 or group 8 element. So therefore, you need a gain or lose electrons. All right, I'm just going through this. I know you know this already. For C, oxygen, it will gain 2 electrons, right? So it gains 2 electrons. It's a group 6 element. Sodium will lose electron because it's a group 1 element. So it loses only 1. All right, so straight off the bat, A. All right, so this paper is really, I would say, relatively easy paper. It's a sweet paper, you know. So hopefully you're lucky enough to get something sweet as this one. Now, question number 34 is that which statement about group 1 metals is not correct. So we're looking for the not correct version right here, right? And so they said their reactivity decreases down the group. We just talk about that for metals. When going down the group of metals, reactivity increases simply because the atomic radii increase going down the group of metals, right? And so it's not true. A matter of fact, no, it's not even true for no metals at all. All right, so that's the answer right there. They don't need to go through it. If you want to go through the other points, that's fine. A matter of fact, let me run through them real quick. It said they have relatively low melting and boiling point, which is not necessarily true. They have high melting and boiling points because they're really harder to break down and melt and all those type of stuff. All right, they react with water to produce hydrogen gas, which is a true thing, because they really, well, most metals, especially reactive metals, they're highly reactive with water. They should not be react with an acid in a high school lab because of the danger of reacting them and how reactive they are with acid. And of course, they can really explode as well. So therefore, it's not recommended for you to do that in an high school lab. It requires a lot of safety measures and precautions. So we don't do that in a lab. And please do not try to do it in a lab, all right? Please. All right, so question number 35 is which group in the periodic table has elements that exist as monatomic gases? And when we talk about monatomic gases, we're talking about only one atom, okay? So group 8 or group 0, they are, for example, helium, neon, argon. They are gases, but they are monatomic gases. Group 5, they are not gases. With the exception, of course, if you have nitrogen gas, and it's an N2. So I could change this for group 5 and say N2 because here you have N2. So I'm just going to change this to N2, right? So I'm going to put N2 right here. So it's a diatomic gas, all right? And so let me just write that properly. So you have the correct thing. Let's put a 2 right here. All right, good. So yeah, so that's what you'd have there. All right, and of course, group 6, for example, oxygen, which is O2. Group 7, Cl2, which is chlorine gas. So they are diatomic gases, okay? So the one there off the bat is really group 0 or group 8. All right, so go to question number 36 at this time. Now we say platinum is an expensive metal. Indeed it is. It's a which statement explains why platinum microscopic wires, which are called nanowires, are used as catalyst in fuel cells. All right, I have 2 answers right here. I'm going to tell you why I have 2 answers here. One, option A is a correct answer. It gives the reactants more energy because, of course, again, they are small, and so it's spread out and give more energy to each particle, right? And these are also correct because, again, it makes the reactant move faster. So if you give the reactants more energy, naturally they will move much faster. Again, the kinetic theory applies here. But for B and C, they're kind of tricky. Because one, for B said it increase the concentration of the reactants. You're not changing the concentration of reactants. If you have reactants already, the most you can do is to increase the speed of how these particles move. The faster they move, the more bombardment of these particles, which mean faster reactions as well. But they say in a fuel cell, so it's not really increasing the concentration of the reactants itself. It said increases the surface area of the reactants. Again, higher concentration tends to have more surface area, which means more particles per volume to react. All right, and so you have more bombardment of particles or collision of particles. So these two they are nice answers in terms of general reaction of the substances once they have high energy and also move faster. So this question is a really tricky intertwined question, but my best answer for me personally, I'll go with A and D. All right. I'd love to see what the examiners will go with as their final options. But A and D, for me, would be the correct options. All right, so question number 37 is that during the extraction process of aluminum, the carbon anode, and I just want to make a note right there, the carbon anodes, which is positive, anodes are positive, have to be replaced periodically. What statement explains this? And the answer there is actually they are oxidized because they lose the electrons. So because you have lots of electrons taking place, they will actually break down. When they oxidize, they start to break down and stuff like that. So you really have to replace them over a period of time. All right, the other options are not correct, all right? 38, it said information about an element is displayed in the table. And it said which element is a metal. And so, without even a lot of explanation for this, charge on the element, once you're a metal, it must be positive. So off the bat, it must be between C and D. And then again, in terms of electrical conductivity, metals are good conductors. So therefore, the answer here is C. All right. So by process of elimination, C is our answer. 39 is which atom has 2 more electrons than an atom of a noble gas. And remember what a noble gas is, the valence shell is 8. So what I kind of did is to work out the electron configuration for all of these elements. On a typical circumstance, they will not give you, well, you don't know how, most of you will not be able to work out the electron configuration for the elements above the first 20. In other words, beyond calcium, you're not able to work out those because the rule actually changed. Because we know about 288, right? But once I pass the first 20 elements, there's the 288 doesn't apply anymore. All right, we have to use the Bohr's model or the Bohr's number. And so we have 2n squared. All right, but we get into that another time. But I've done it for you, but you don't even need that, to be honest with you. You really, really don't need it. I'm going to explain to you why, but I just like to break this down, just in case some of you want to go through it and understand it is also fine. So aluminum is from group 3, right? And so therefore, the electron configuration is 283 because you have 13 electrons. And so you have 3 more compared to a noble gas because a noble gas has 8 electrons on its valence shell. All right, for the first 20 elements. I'm going to putting that piece in. Now, bromine is from group 7, right? So therefore, the valence shell has 7. So it has 7 more than a valence, than a noble gas, or even 1 less. It could be 7 more or 1 less. We think about it in that sense, right? All right, so it could be 1 more to make 8, or you have 7 more. So it depends on how you look at it. Really don't matter because they say the statement here said 2 more, right? Which has 2 more. So it has 7 more or 1 less. Now, magnesium is from group 2, and all of these will have 2 more than a noble gas. And so you have 2A2. So if we take off this 2 at the end, this 2 valence electron here, make it 2 more than a noble gas. Right? This is a straightforward thing, as I said to you. Rubidium has 37 electrons, and the electron configuration is 2, 8, 18, 8, and 1. So it's in group 1, of course. It has 1 more than it. All right, so the answer there is actually magnesium. Again, you can use the group to determine this as well, right? The group will tell you. So group 1 has 1 more. Group 2, 2 more. Group 3, 3 more. Group 5, 5 more or 3 less. Group 6, 6 more or 2 less. Group 7, 7 more or 1 less, right? So it's kind of easy question, but I just like to show you the possibility of actually thinking about it in different ways. All right, question number 40, and we are almost there. All right, so which statement best explains why iron window frames on a bus close to the sea? Matter of fact, let me read back this question. I think I missed something in the question. It said, which statement best explains why iron windows frames on a house close to the sea rust more quickly than ones further inland? So the house is closer to the sea with iron frame on it, which is not a good way to build any house in the sea with iron at all. Basically use PVC or things that will not rust. Cast stainless steel and so on. So the answer here is that the sea spray contains salt, dissolved salt or salt dissolved in the water, and the salt that dissolved in the water will cause faster oxidation of the ions, which means faster rusting and all of these things. So definitely A is the correct answer there. All right, so it's not a good idea to use anything that contains iron if you live on the seaside, all right, or in the beachfront. All right, so 41 is which one of these elements shown is not a diatomic molecule? Again, this is a kind of a similar question we did with the monatomic up there. So now we'll talk about diatomic. And so chlorine, as we mentioned, yes. Hydrogen, yes. Oxygen, yes. Sulfur is not a diatomic molecule at all. All right. All right. So let's go to 42. No debating about that one. 42 is which of the non-metals shown is a colorless, odorless gas that relights a glowing splint. A matter of fact, if you don't even know about colorless or odorless, what you should know about is which gas relights a glowing splint, and that is oxygen. Oxygen is needed for combustion. So D is the correct option there for 42. For 43 is which of the following properties characteristically represents a non-metal? So in terms of the characteristics of nonmetals, right? I want you to remember what nonmetals are. And I guess you should know this. I know you did this probably from grade 10 or earlier. But a nonmetal now will form negative ions. So definitely A is out, right? The high electronegativity, yes. And why? Because the nonmetals generally tend to attract electrons. And when we talk about electronegativity, is the ability to attract electrons, right? High melting point, the melting point tend to be low. Reducing agent, no, they're really oxidizing agent because the fact that they will take electrons from other elements, and so they will cause those elements to reduce by losing their electrons. All right, and so that's what oxidation is. And that's what, yeah. So we said reducing it. So that's what reduction is, to lose the ability to lose those electrons. All right, so it causes the elements to lose electrons. So them themselves gain electrons. All right, and so here now, 44, it said what is the general formula of an alkene, and so you need to know what are alkene, alkane, and alkyne, and so CnH2n is not a formula for nothing at all. So -1 is not a formula for anything. CnH2n, yes, that's for alkene. CnH2n plus 1 is not a formula for nothing at all. And this is a plus 1 something, like it's a plus OH or plus, to give, or plus COOH. That's different. But just plus 1 by itself now is not a formula. For D, CnH2n plus 2, which is alkane. So that's a valid formula. But again, our alkene is actually B. And of course, alkyne would have been -2 instead of +2, right? So B is the correct answer for 44. 45 is what is the main constituent of natural gas? So the main constituent of a natural gas is actually methane. Methane is one of the major components of natural gas. All right. 46. 46 is a carbon monoxide, is an air pollutant produced when gasoline is burned in a car engine. It said why is carbon monoxide considered to be an air pollutant? And notice I highlight air pollutant. All right, it causes climate change. Yes, it does, but not because it causes climate change means that it's an air pollutant. But the correct thing you're looking for, why is classified or considered air pollutant? It causes corrosion to buildings, not itself directly, but of course when it starts to mix with water and so on, and because of the pollution of rain, then yes, it could cause that. But it's not the reason why it's called a pollutant. So listen this now. The third option, option C, it is a significant greenhouse gas. So because it's gaseous, and it's a greenhouse gas, which means up in the atmosphere, so it's polluting the air, which will destroy the ozone layer, right? Of course, it's poisonous to our body. Carbon monoxide is definitely poisonous to our body. It prevents hemoglobin from absorbing oxygen. So it is poisonous, all right? Because you read about carbon monoxide poisoning, but it's not because it is poisonous why it's considered an air pollutant, all right? It's the gaseous nature of it, and it also the ability to mix with the greenhouse gases. All right, so 47. So which substance is not essential for the formation of ethanol by fermentation? And light is not needed for fermentation to take place, because fermentation is really a form of respiration, but it's anaerobic respiration. You require sugar, you require water, and you require yeast, which is the organism that will respire to produce the alcohol. Light is not needed. All right? All right. And again, it's anaerobic respiration. 48, and we almost there. It said global temperatures have been steadily rising. It said which has been the greatest contributor of these increasing temperatures? And it's the burning of forests, that's a big thing. Burning of fossil fuel, that's a big thing. Exhaust from motor vehicles is also a big thing. And again, melting of the polar ice cap is a result of those things. So which is the best one? And it said greatest contributor. And fossil fuel is the greatest one. Why? Because of course, exhaust from motor vehicles is because of burning fossil fuel. So fossil fuel is not just motor vehicles alone. It could be industrial, like factories. So it's a wider spectrum of things happening on the burning of fossil fuel. All right. Burning of forests is not a all everyday thing or common thing. So burning of fossil fuel is a wider scope, so therefore that would be the best answer. All right. After that, of course, exhaust from motor vehicles will be the next one. 49 is a sulfur dioxide, carbon monoxide, and oxides of nitrogen are common gases pollutants found in the air. Which pollutants contribute most to acid rain? All right, and the one that contribute most to acid rain is really carbon monoxide and sulfur dioxide, right? Nitrogen oxide is not that common to cause acid rain at all. So therefore, option B is our correct answer. And for our grand finale, question number 50. Which element do plants need for healthy growth? And that is right off the bat, nitrogen. Because nitrogen is used to build proteins, all right? And they get nitrogen, plants get nitrogen from nitrates, just to mention that. All right, so plants get their nitrogen from nitrates, and the purpose of nitrogen in the plant is really to make protein. Protein used to make new cells, the plant will grow. All right, and proteins need to make like enzymes and all those things, hormones and all of those things that needed for growth and so on. So nitrogen is indeed the correct answer. And so at the end of it, and I hope this was really helpful. And I also want you to share this with your friends, help everyone to come on, help spread the word. And please, if you haven't done so yet, also hit that subscribe button. Talk to you soon and have a safe and blessed day. Good luck on the examination.